do. Okay. Today's date will be 8/28. And your names goes on top of your paper, and this is number 4. Okay. This you do not have to write down, but I want to show you some square roots. Square root of 1 is 1. Square root of 4 is 2. The square root of 9 equals 3. The square root of 16 equals 4. The square root of 25 equals 5. The square root of 36 equals 6. The square root of 49 equals 7. The square root of 64 equals 8. The square root of 81 equals 9. The square root of 100 is 10. And it goes on. Okay. When it comes time to doing approximations, we use this chart right here to figure out what the approximation of a root that is not perfect, or should I say a number that is not perfect. Some examples of that. Let's say I had the square root of 10. The square root of 10 is not up here, but the square root of 10 is between not square root of 9 and square root of 16. That means that the answer is going to be between 3 and 4. If the answer is close to 3, I can use numbers like 3.1. If the answer is close to 4, I can use answers like 3.9. If the answer is in the middle between square root of 9 and square root of 16, I can use numbers like 3.5. So this is a judgment call. Again, if this number right here is closer to this number, I would use 3.1. If it's closer to this number, I would use 3.9. And if it's right in the middle of 9 and 16, I would use 3.5. So the question is, what do we use for square root of 10? Which one of those three would you use for square root of 10?
3.1.
Exactly right. It's closer to the 9. So that's approximately 3.1. Finished. Next. The square root of 50. The square root of 50 would be between square root of 49 and the square root of 64. Now, would you use 7.1, 7.5, or maybe 7.9? Those are about 3 choices that you could use. Ribbon, which one would you use for the square root of 50? 7.1, 7.5?
More about 7.5 for me.
Okay, not bad, not bad. What would you say? Oh, Sims. You use 7.1, not bad, not bad. Andres, which one would you use for the square root of 50? Which one of those?
49, not 45.
It looks like a 45.
It does sound like
Oh, okay. I'll fix that.
Now it said 7.1.
Okay, so you're changing yours to 7.1. Okay. What would you say, Andres? Square root of 50 is between square root of 49 and between square root of 64. It is between those. But would it be closer to the 7, like 7.1, or would it be closer to the 8, like 7.9, or do you think it's kind of in the middle, 7.5? What would you say? Yep, the square root of 50 Would it be closer to this one or closer to this one or somewhere in the middle?
45.
I agree. So since it's closer to 49, the idea is 7.1. K. Okay. Oh, you're listening there?
Yeah, 7.1.
You would also, okay. Guys, I agree. 7.1 is a better choice out of those three. Good job.
No.
All right. Next, square root of 15. Square root of 15. Square root of 15 is between square root of 9 and square root of 16. The question is, what would you use?
3.9.
Exactly. Good choice. Because it is closer to this one, I would use 3.9. Good job, guys. Now, when you guys do solve these problems, you can have a little cheat sheet of this on the side. I don't mind. So if you guys want to use a little index card, you can use that. That's no big deal. All right, next. We have the square root of 24. All right. Beckett, what would you say the square root of 24 would be?
Hold on, I want to make sure I got everything. Okay. Square root of 24, I'd use 4.9.
Yeah, good choice. I would use 4.9 for that. Good job. Okay. And number 5 is the square root of 75. Okay. This question would go to Sims. What would you use for square root of 75? Say again? Yes, exactly. Well done. Between 8 and 9, there's 8.1, there's 8.5, and there's 8.9. 75 is in the middle, so I would use 8.5 for that. Very good. Very good. Okay. Next, let's talk about simplifying roots. We have the square root of 8. Okay, exactly as I do. Exactly as I do. 8 factors into 4 times 2. And then 4 factors again into 2 times 2. Once you got all your factors, 2, 2, and 2, you circle the pairs. Circle the pairs. That's a pair. In fact, that's the only pair. Okay. Everything that you circle goes from 2 to just 1. It cuts it in half. So everything that you circle, so these 2 2s become a single 2 on the outside. Anything that's not circled goes on the inside. Anything that's not circled goes on the inside. Finish. That's how you simplify a square root. Okay, let's do it again. Number 7. Number 7, we have the square root of 18. So I'm going to start factoring that. First question is, what times what is 18? And I'm going to use 9 times 2. Okay. 2 is prime, so I can't break that down, but 9, I can break that down into 3 times 3. Now, I find all my pairs. And I get my root ready. Okay. Everything that's circled is going to reduce down to one single term on the outside. So these 2 3s become a single 3 on the outside. And that 2, which is not circled, goes on the inside. 8. 8, we have the square root of 20. Okay. First question is, what times what is 20? 10 times what?
2.
Yes. So we'll start off with 10 times 2.
Or 5 times 4.
Yes, and there are plenty of choices. And there is no wrong choice. Because when you do all your factor trees, all your factors, you'll get the same answers at the end. So 10 becomes 5 times 2. And that's as far as we'll go. Now let's look for the twins. These are twins. So they get circled. Okay. All your twins get cut in half and go on the outside. All your twins get cut in half. So these two 2's become a single 2. And there he is on the outside. Whereas this 5 right here goes on the inside, and we're finished. Okay. Next, the square root of 50. Yes.
I know the dimension of the second column is one of the questions that are the same on the first column.
Oh, I repeated something?
Yeah, you repeated.
Okay.
Number 3. You repeated number 7 is number 3.
On something.
Consider it a free one, so just repeat the other answer. Yes.
10 and 5.
10 and 5. Let's do it. 10 and 5. Very good.
5, 2.
5, 2. Well done. That's it. That's as far as we can go. And here's my circle. Isn't that a lovely circle?
Peanut.
I think that's beautiful. It's dark in here. Next, your root. Okay. Outside the root goes what?
5.
The 5, right. But inside the root goes
2.
finish. That's it. That's it. And the last one is number. Sorry, the next one is number 10, 75. That's a big number.
One of the realization dominators.
Sensei.
Yes.
For the second and third column, you went from 5 to 3 back to 6 and then to 10 on the numbering.
Oh, wow.
Yeah.
Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it looks okay.
Not on my sheet. My sheet goes 1, 2, 3, 4, 5, 3, 4, 5, 6, 10, 11, 12, 13.
Whoa. Okay. Are the problems the same?
The problems are the same, yeah.
Okay, so I mixed on your sheet. Okay. I will fix that. I must have printed that. That's like an old version before I fixed
Yeah,
it.
I can see it on Francis' sheet.
Yes, he listed on the first column. He didn't start over again after the first release.
Okay, so they need to be renumbered. So go ahead and scratch my old numbers out and put the real ones in. Okay. Oh, excuse me. 75, guys.
Times 3.
Yes, very good. 25 times 3. Very good. So far, so good.
5 and 5.
5 and 5, yes. Okay, we got it. So now we get the root ready and we circle our pairs. Okay, so the 2 become 1, 5. The 2 becomes 1. And it goes on the outside. Then what goes on the inside? Yeah, the 3. Very good. All right. Okay. Here's the last problem. Rationalizing denominators. Okay, we got 11, which is 3 over the square root of 2. Okay, exactly as I do. I want you to write 3 over the square root of 2 again, a second time here. And next to this, we're going to multiply the square root of 2 times another square root of 2. Square root of 2 times another square root of 2. And the rule in math is in fractions. Whatever you multiply with the bottom, you also have to multiply with the top. So we have to put another square root of 2 on top as well, because we put this one here.
2.
Yeah, well, square root of 2. I'm using the square root of 2 here for this one, but you got to put another one on top. All right, so here we go. 3 times the square root of 2. Those two do not blend together, so you can just write them next to each other. They don't blend. But square root of 2 times square root of 2, those do blend. So square root of 2 times square root of 2 is square root of 4. And square root of 4 is on the chart right here. 2. So this changes to the number 2. Finish. And that's how you get a root out of the denominator. In other words, they call it rationalizing the denominator. Okay. Let's do another one of those. That was nice. That was nice. Number 12. Number 12, we have a 10 over the square root of 5. 10 over the square root of 5. And we want to get rid of the square root of 5 because we don't want that square root down there. So we write 10 square root of 5 again underneath. And then multiply the square root of 5 by another square root of 5. Multiply the first square root of 5 by another square root of 5. And whatever you do to the bottom, you've got to do to the top. So we put another square root of 5 here. Okay. Next, 10 times the square root of 5 is 10 times the square root of 5. Because those two do not blend. Question, what is the square root of 5 times the square root of 5?
What?
Square root of 5 times the square root of 5.
25.
The square root of 25. Now, the square root of 25 is right here, and it equals 5. So, this becomes 10 square root of 5 over 5. This one has one more step that the other one does not have. 3 cannot be divided by 2. That's why we stopped here. But 10 can be divided by 5. What is 10 divided by 5?
2.
2. So the final answer is 2 square root of 5. Because 10 can be divided by 5 and give you a 2. 13. Square root of 3 over the square root of 2. Okay. On this one here, we're going to write it again. Square root of 3 over square root of 2. Write it the second time. That's called preserving the integrity of the original problem. Then I'm going to multiply the bottom by another square root of 2. Square root of 2 times another square root of 2. And whatever you do to the bottom, you have to do to the top. So I'm going to use another square root of 2. Okay. Now, before we could not multiply the tops. This time we can. What is the square root of 3 times the square root of 2?
6.
Square root of 6. Yes. And for the denominator, square root of 2 times the square root of 2 ends up being the square root of 4. Okay. So take a look. There is no square root of 6 here. There is no square root of 6, but there is a square root of 4, and we'll change it to a 2. And we are finished.